Okay, hi. So we are going to solve on test 1 2017-05 question number 3. Okay, so two blocks are connected by a light inextensible string as shown in figure 3. The pulley is frictionless and the smooth inclined surface. So when we heard the word smooth, it means there will be no friction. Okay, so makes an angle 37 degree with the horizontal. So this one is 37 degree. When the system is released, the block with mass m falls with acceleration a. So these blocks will fall. Okay, so when this block falls down, this mass will be moved here. Given that m is 2 kg and capital M is 5 kg. Alright, draw the free body diagram for both blocks M and M respectively. So in your answer script, okay, so we're going to draw the free body diagram for both blocks, and we're going to write the equation of forces and find the acceleration of these blocks. Okay, so given that the angle is 37 degree, mass M is 2 kg, capital M is 5 kg. Okay, so we can draw the free body diagram on the picture. Okay, so the first thing, I will solve for block M. Because block M is on a surface, so it has a normal force which is perpendicular to the surface. So this is the normal force. Okay, and block M has a mass, so mass is always directed downwards, so there will be mg. Okay, so block M is supported by a tension, so this will be a tension. Before that, maybe we can define our axis. Okay, so since there will be no friction, if we have friction, the friction will be directed towards here. Since acceleration is here, the movement is here, friction always oppose if we have. So in this case we don't have. Alright, and then for block M, capital M, let's define our axis. Okay, so we have tension and at the same time we have the weight of block M. Okay, so this is a free body diagram. So let's how to redraw into your answer script. Okay, so let's say this is number 1. Okay, so for block M, you can redraw the block, or you can into axis. Okay, this will be your X, this will be your Y. Okay, your X have tension. Okay, so imagine is here, and your mg, the normal force, is here. Okay, but your mg, if I draw imaginary line, your mg is directed towards here. Okay, so it should be somewhere here. So you can resolve. This is already complete free body diagram. We don't have to resolve right now. So if I want to resolve on the picture, theta here by mathematics, it should be the same as here. So this one will be mg cos theta. This one will be mg sin theta. Okay, so this is for block M. Alright, now for block capital M, this is your Y, this is your X. There is no forces in X direction, only Y direction. I will have tension and also capital mg. Okay, so these are the free body diagram for both blocks. Okay, so next they asked, okay, so far this is we have completed the first question. The second question they asked, write the equation of forces x and y component for the two blocks. You may use Newton's second law, all the force must equal to the MA. Okay, so based on the free body diagram, okay, we can derive equation of motion using Newton's second law. So first we need to define that all the forces going up and to the right will be positive, forces going to the left and going down will be negative. And remember, the acceleration block M is going down, so the acceleration is negative by direction, and block M will pull the smaller block to this side, so the acceleration is going to the right. Okay, so let's write for smaller block. For block M, smaller block, what are the forces? For Newton's second law, all the Fx. Okay, since the block, we have defined our coordinates in the x-axis is here, so since the block movement is in the x-axis, so all the forces in x will contribute to the movement of MA. Okay, so what are the forces in x-axis? Tension is going to the right, should be positive. Mg sine theta is to the left, so should be negative. So Mg sine theta plus tension equals to MA. Alright, so leave it. So what are the forces in y direction? The forces in y direction, since there is no movement in y direction, all the forces in y must be 0. So what are the forces in y? We have normal force and also mg cos theta. So n minus mg cos theta equals to 0. Okay, done. So what about block 2? Sorry, block capital M. Okay, so M move in y direction, so all the forces in y direction must contribute to the movement of block M. But remember, since A is going down, you have to put negative. Okay, so what are the forces in y direction? We only have two, tension and also the weight. So tension is going up, we define as positive. Mg is going down, we define as negative. So T minus Mg equals to negative Ma. So this one, do not make me confused with the smaller m, so I put this kind of like this m. Okay, so let it be this equation. So there is no forces in x, there is no movement in x-axis. So this is to answer question number 2. Next, they ask you to find the acceleration as usual. Okay, so now if you look at equation for block M and the bigger block, you will see that we have the same tension. Why we have the same tension? So tension is the same because they are connected by a single cable. So tension is the same. So from equation number 1, okay, from this equation I rearrange. So this is my first equation, this is my second equation. From 1, I rearrange T equals to MA plus MG sine theta. Okay, from equation number 2, T equals to negative MA plus MG. So because they are the same, I can equate 1 equals to 2. So MA plus MG sine theta equals to negative MA plus MG. So bring all the terms with acceleration to the other side. MA plus MA equals to mg minus mg sine theta. Factorize acceleration, m plus capital M, mg sine theta. So acceleration is mg sine theta over m plus capital M. Now you can substitute all the values. 5 kg, 9.8, on 5, 9.8, 2, 9.8, sine 37 degree over 2 plus 5. Then you can present your answer in terms of meter second squared. Okay, that's it for question number 3.